Stroll nicht, und wenn das Herz auch bricht.
Okay, we're going to start into doing some German problems here. Normally we would be doing, 3 to 4 days of Chapter 11 German problems, as well as 3 to 4 days of Chapter 12. We'll be doing some German problems at the end of each of those chapters. We're just going to do one page of the packet here, just to give you a flavor of what these German problems are like. To me, it's the most fun part of the year, and so I want you to at least experience one page of it. So what I'm going to do is I'm going to give you some hints as far as how to read some of these problems here. I'm going to give you the opportunity to do the problems. I would say spend about 45 minutes to an hour working on these problems. They're pretty tough. And then I will post, at the end of this video, I will post the how-to on how to solve these problems. So, like I said, these are problems that are German problems. They're actually in German, and they are from Germany. Our superintendent, Mr. Sally, is actually the one that brought these to the math department. He used to be a math teacher, and so I'm going to talk you through some of these things. The first problem here is where this W is whatever. This basically means that this W is an angle bisector. So this guy right here is an angle bisector. Something else you should know is that these little dots there indicate that it's the center of the circle, where this is the arc of that centered circle. Also, this little marking here is a right angle. So you'll see that all around the page. And then these guys are the variables that you are solving for. So in this particular case, this is alpha, there's delta, there's a beta. So there's a bunch of different variables that you need to solve for here. Okay. What else do I need to? Oh, I know. Down at the bottom here, this symbol here and this symbol here means parallel lines. Okay. And I think that's about it. There's a lot more German on a lot of the other problems. This is also parallel lines here. Okay. And let's see what else we got here. I think that's it. Okay. So what I'm going to do is I'm going to give you the answers and let you guys shoot for these answers. This first one is 12. Number 9 is 11.5. Number 3 is 63. This one here, alpha, is 78. Beta is 51. I think that's a gamma. That's a 27. Same thing here with these variables. This is going to be 60, 75, and 82.5. For number 13, the answer is 68. For number 7, it's 66. For number 15, the answer is 42. For number 2, the answer is 6. And for 166, the answer is 30. Okay, and this is, like I said, from Chapter 11, so you have to use the material from Chapter 11. And go ahead and give it a try. see if you can get those answers, and then I'll be back later in the video to go over these problems. All right. Okay, let's go over the first two here. Problems 1 and 9. So the first problem here, this is 90 degrees. This is 44. We know that this is an isosceles triangle because this is the center. And so I know that the corners here are going to be 68. And of course this whole thing over here must be 68 also. And I know that this is an angle bisector. So I know this has to be 34. If this is 90 and 68, I know that this bottom angle here is 22. Subtract 22 from 34, and I get 12 for my answer. For number 9, let's see, this is 90, this is 23, so I know that this bottom angle down here, this triangle, is 67. I also know that this is 23 here, and this is the center of the circle with this arc. I know that this angle down in this corner here must be 78.5, as well as this whole angle also is 78.5, which means that this angle right there I can get from 78.5 minus 67, or I can take this angle here as the right angle and subtract it. In either case, it's going to be 11.5. Okay, looking at problem number 3 here. I know if this is 141, I know this must be 39. And I can draw in auxiliary line here, which makes this angle also 39 because of this isosceles triangle here. And I know that this angle here is the exterior angle. So using the exterior angle theorem, this is 78 because it's 39 plus 39, which makes this also 78 because it's an isosceles triangle, and that makes this angle 24 because that's an isosceles triangle right here. And so this angle is just going to be 39 plus 24, or 63 degrees. Number 11, I know this is 24, that these two angles, so it's going to be 24 plus 2 times this angle, 2 alpha is equal to 180. That means that that angle has to be equal to 78. That's 78. And that's 78. I can focus on this triangle right here. And I know that 78 plus 2 betas has to add up to 180. That means that beta is going to be equal to 51. And then if that's 51, I can kind of back into this angle over here. I can look at any number of triangles, but ultimately that angle is going to end up being 27. Okay, on to number 5. Number 5 here, this is a right angle. These are all the same, which makes these each 60. If I focus on this triangle right here, this becomes 30. And then these two angles have to add up with the 30 to 180. So these are both 75. And then if I focus on this triangle right here, that makes this 15. Then you have the isosceles triangle here, which makes this 82.5. Okay, number 13 is one of the tougher ones for sure. You need to draw in an auxiliary line here and recognize that these are parallel lines. And so if this is 92, these two angles here and here are going to be same side interior angles, so those are 88. That has to be 88, which means this has to be 88, because it's an isosceles triangle right here. And then you can see that because of the parallel lines, that this 88 and this little angle, this partial angle here, is also 88 because they're alternate interior angles. And now that makes this arc right here equal to 88 because that's a central angle. And I'm going to draw in another auxiliary line here. This auxiliary line goes right across like this. And if you look at this angle right here, with it, it's an inscribed angle which eats this arc right here. So it's inscribed, which makes this 44 degrees. It would be half of the intercepted arc. And then now you have to recognize, this is the tough one, you have to recognize that this side and this side, those are side legs of an isosceles triangle with this vertex 44, which makes this angle and this angle the same, and that means that both of those are 68 degrees. Okay, moving on to number 7, you have to draw in a couple of auxiliary lines here. Right there is one, and then right here is another auxiliary line. That makes this an isosceles triangle here, that's 16. That makes this angle, it's going to be 148, which makes this 32. This is also an isosceles triangle, so this is 32. That makes this 116. And then I subtract from 180 to get that this is 48. And it's another isosceles triangle, which means that both of these guys, these base angles are the same, which makes these both 66. This next one, you have to draw an auxiliary line from here to here. At least that's how I did it. And this is going to be 64 vertical angles. This is going to be 116, as well as this vertical angle is 116, which means that these two base angles, 32 and 32, right here and here. And that means that this arc right here, because this is the central angle for that arc is going to be 32. And now I can do, these are going to be half the sum of these two arcs. Let's call this arc, we'll call it x. So it'll just be x plus 32 divided by 2 is equal to 64. So x ends up being equal to 96. That's going to be that arc. You know by subtracting from 180 that that's got to be 84. And then I know that this angle here, this alpha angle, is going to be half of that 84. So this must be 42 because it's an inscribed angle. Okay, down to our last two, both of which aren't too bad. If this side length here is x, this also is going to be x because of this arc right here. It's an isosceles. These are both radii, which means that if this is 2 from here to here, I know that this whole thing, because these are both radii, is going to be x plus 2. And this, by the way, means this is a perimeter. And so that means that x plus 2 plus x plus 2 plus x is equal to 22. Solve for x. X ends up being equal to 6. This next one here, you have to draw an auxiliary line from here to here. And this is going to be a right angle here. And if these are parallel lines, then I know that these are alternate interior angles, so this is alpha. And if these are radii here and here, these are congruent to each other, so this is also alpha. And so that means that this whole thing is 2 alpha, so this angle here must also be 2 alpha, looking at this triangle here, with those being the radii. And so now I can do alpha plus 2 alpha plus 90 is equal to 180 and solve for alpha. And alpha ends up being equal to 30. And that's it.
Ich trolle nicht, und wenn das Herz